Hi everyone, my name is Glen, Chief Operating Officer at Spartan Solutions. And today I want to talk about trust. How can we build trusted artificial intelligence solutions to support the utility industry? And in particular, how can we build trusted AI to support the operations and maintenance of offshore wind farms? Now, I've chosen operations and maintenance because together they account for more than 50% of the total OPEX of a wind turbine farm. Now, as well as a high operations and maintenance cost, we also have an emerging skills crisis within the industry. The UK government has committed to delivering 40 gigawatts of energy, and currently we deliver 10 gigawatts with the existing workforce, and it's already very stretched. Now, as well as this, we need to extract and share the knowledge that OEMs currently have as the existing turbine support contracts start to expire. Another challenge is artificial intelligence itself. AI is a relatively new technology in the industrial sector, and there is a lot of hype, fear, uncertainty and doubt surrounding the technology. Will it work at scale? Will it replace our jobs? How can we understand and trust what the AI system is telling us? We have been deploying asset management solutions to industrial companies for over 15 years. And for the last 18 months, we have been implementing a Profis AI solution to the renewables, oil and gas, and equipment rental markets. Now, AI covers a wide spectrum of techniques, and our product uses two of those techniques: expert systems and machine learning. Expert systems and expert rules capture knowledge as a cascading sequence of if-then-else rules, whereas machine learning uses labeled data as its input. The labels are provided by domain experts, and they're used to generate models that use complex mathematics to recognize patterns that match the labels. Now, we've used both approaches in our projects, and what we have found is that you should start with expert rules. And there are three reasons why. The first is that they are relatively cheap and easy to implement. Now, we created over 40 expert rules for an offshore gas compression system, and that was spending just 2 days with their domain experts. Expert rules are also explainable. When a rule fires indicating an emerging fault, any trained expert in that plant can interrogate the rule and its input to understand why it came to that decision. And that is really important for building trust. The other thing about expert rules is that they are transferable. A rule built for one turbine can be easily converted to another turbine in the same farm or even a different farm. Now, machine learning can be more accurate, often is more accurate than expert rules, but for that accuracy you pay a price in explainability. And for example, we built a supervised model for a gas compression system offshore, and it was trained using labels generated by the maintenance management system and the production loss system. And it was very accurate at predicting gas seal failures. 81% of the time it would accurately identify an emerging gas seal failure. But it's a black box. It's a deep mathematical model generated by the training process. So even though it could save millions of pounds per year per platform potentially, engineers were very wary of the results. So there is a big trade-off between accuracy and explainability. And black box models are important as a tool, but we believe you should use them once you've built up trust using expert rules first. The second thing we learned is to keep it simple. Users want tools that are powerful but easy to understand. Now, maintenance experts work in a high-pressure environment where the impact of failure can be very high. One instance can cause tens, hundreds of thousands of pounds of lost production. So you have to keep it simple for end users and not overload them with too much information. Now, the first generation of PC-based predictive tools are very complex, and they often require months of training and years to master. Now, the latest generation of tools are cloud-based, with easy-to-use web interfaces that users can quickly understand and master in hours, not weeks or months. And this ease of use also builds trust. And the third thing that we learned is that you should try before you buy. Just as you wouldn't buy a house without looking at a few others that are similar, we don't think you should invest in predictive maintenance solutions until you try a few of them out. Now, we recommend short, focused pilots that let your users get hands-on with the tools themselves. And a pilot can also allow your executive team to test and measure the actual versus the expected benefits. We use these three principles in a pilot we recently completed with a large European offshore wind farm operator. We modelled 2 years in the life of 140 offshore wind turbines, and we worked with the customer's equipment experts to build a range of expert rules that could be used to continuously monitor the performance of ancillary equipment. And the results were very encouraging. For example, the Profit solution could reliably predict I/O board failures caused by hydraulic oil temperature drops. We could also recommend the optimum coolant pressure refill window, and we could filter out false smoke alarms. We could remove 95% of the alarms that were actually false alarms. Now, as a technology provider, we have a duty to make it as painless as possible for operators to start this journey and trial the latest AI tools. And we must also keep it simple for the equipment experts to use these tools while making the first wave of AI models understandable to build up that trust. And this is the way we build up trust in this new technology. And once we trust in the AI, it can help us capture that expert knowledge that can then be scaled up and automatically applied to hundreds of thousands of wind turbines in real time. And we have seen from our deployments across oil and gas and renewable assets that the increase in production and reliability, combined with the reduction in OPEX costs, can make this journey very worthwhile. Thank you very much for your time today.
Thank you very much, John, for that. Couple of points I would just want to raise before I ask you some questions. I think you touched upon it in, the beginning of your presentation, how people sometimes have this, and I will say it again, this misconception about technology. They see it as a replacement of their role. And I mentioned this in my welcoming speech, as opposed to a facilitator. And I sort of do agree with that because, we work together within oil and gas and we've covered very similar themes. And I think that's something which is resonating through energy in sort of heavy industry. So very interesting you sort of mentioned that. And also I like the try before you buy, because there's if there's a bit of a, as we've seen from panels, apprehension of taking on technology because of different reasons, it's good that companies like you can do that. So good for you to sort of offer, and good for everyone to know as well. You mentioned, John, that you've implemented predictive maintenance in oil and gas. Can you tell me, because obviously this is a utility-based event and a power and energy-based event at DNOs, what lessons can the utility sector learn from from how oil and gas deploy AI?
Well, hi Adam, and first of all, thanks for the invite. It's great to speak to you and the delegates today. I think the first thing I would say is that all the sectors, Adam, can learn from each other here. In our experience, there's no one industry that has the answer. So collaboration is the key. In fact, Sir Jim MacDonald from Strathclyde University talked about private industry working with public sector and academia to drive this innovation. And we know this approach works well because we've used it in the oil and gas sector. So as an example, we partnered with the Oil and Gas Technology Centre, which has now been renamed the Net Zero Technology Centre, and we also work with Strathclyde University and Repsol Sinopec, a big operator in the North Sea. And that triumvirate helped develop Profis, which is our predictive analytics solution. So that partnership gave us access to funding, it gave us access to data, and it gave us access to world-class machine learning experience from the Strathclyde University EEE team. And I would say the oil and gas problem is very similar to the problems that the utility and energy infrastructure operators will also be seeing, which is you've got lots of mission critical plant and equipment. There's a big drive to increase reliability, increase the uptime of the energy producing assets, and all the same time reducing OPEX costs. So we are seeing the pilot projects in the North Sea demonstrating real value, strong, kind of almost no-brainer add-on business cases, if such a thing exists. So we're now using Profis to monitor not just offshore equipment, but also we've just completed a pilot with a large offshore wind turbine farm where we're monitoring ancillary equipment within each of the turbines. So we're proving it is, it's a lift and shift, to use that phrase I heard this morning. It's a lift and shift of technology and use cases from one sector, in this case oil and gas, to the energy and utility sector. And I think the ability to use cloud-based, affordable analytics in energy is really exciting, because there's different business models, as you probably appreciate, between the two sectors. So yeah, I think there's a few things that utility can learn from oil and gas, I would say.
So you saying about, obviously there's similarities between utilities and oil and gas industry. What barriers do you see within the utility side for adopting AI?
Yeah, well, I'll focus on predictive analytics and predictive maintenance, because this is the area of AI that we're experienced in. And if I compare utilities to oil and gas, I think we see three differences. And the first one, probably the biggest one actually, is access to data. So at the moment, it's easier to access high quality data from a 30-year-old offshore oil and gas platform than it is to get it from a fairly recently built offshore wind farm. And that surprises me, because wind turbines are, they're newer on average. Both of the industries use the same underlying technology stack. They use data historians to manage telemetry, use computerized maintenance management systems to manage work orders, production loss systems. So what we've noticed that's different is access to that data. So we tend to be limited to SCADA data, which is kind of a 10-minute average snapshot of what's going on in an offshore turbine. And that's an order of magnitude less data than we get from an offshore platform at the moment. So there's smart equipment out there in the utility space, there's lots of sensors, but quite often there's no direct access to the data. And I think that is and will be the biggest barrier to AI innovation. And data democratization, massive topic in itself, and it was discussed quite heavily at times this morning. That has to be the answer. We're a user of industrial sensor data, so I hope the industry can solve it soon. Now, we still get very good results with 10-minute SCADA data, but I'm just wondering how much better the results could be if we could really open up the data and get access to it. So that's probably the biggest difference. I think resistance to change is always a big challenge, and that cuts across all the industrial sectors that we work in. I spent a lot of time talking about trust recently, but there are other factors at play. It's a very regulated industry. There are big risks that have to be managed carefully, and there's an engineering mindset that can sometimes arguably not be as rewarding to innovation as it is to managing risk. I don't think there's any easy answers to resistance to change. Our current approach is to reduce the complexity of the tools, make it easy to pilot, increase the transparency and trust. But I think, again, it's another massive topic, Adam, that you could probably get a panel on and talk about for time. The last thing I'd say is affordability. Different business model in utilities and energy than it is in upstream oil and gas, different cash flow models. So I think the software vendors need to be more flexible, and they need to have transparent and flexible kind of cloud-based, software as a service-based charging models, pay-as-you-go, and try and make it really as simple as possible to buy. I think there's still too many unpleasant surprises for people buying software at the moment. So I think transparency and simplicity in the pricing model is as important as it is in the actual user experience.
It's a good comment as well. I think there's, you talk about how to increase trust with some of the companies, and what you're doing there. You mentioned obviously about you can do a pilot of what you're putting together. I think also, like any industry, you've got good companies and you've got not so good companies who produce AI and predictive maintenance and all these wonderful things. And I think that probably needs to be a little bit more regulated. I think also there needs to be more of an openness from the industry. I think once those two things meet, and they will meet at some point, because government regulations and government conformance will make them meet at some point. But you don't want it to get to the stage where they're sort of forced to do it, because then it might be too late. So I think now it's a must-have, but it's a good time to do it, if that makes sense. What do you also see as a final sort of comment about the biggest benefits that this technology gives to a utility?
Yeah, I think, well, like the oil and gas industry, the utility industry has a lot of data-enabled assets, and these assets are expensive to operate, and there's a very high impact of failure quite often. So I think the business case for predictive analytics and predictive maintenance is very compelling. You can reduce OPEX costs, you can improve reliability of equipment, you can maximize uptime and energy production from each of your assets. I think if you can combine those core benefits with an affordable cloud-based deployment model, you can do it quickly, take the risk out of the projects. I think that's a massive opportunity to optimize not just the current energy infrastructure, but a lot of the future energy infrastructure. We talk a lot about hydrogen and other enabling technologies. I think we have to also be designing in, the engineers that are designing these new types of asset, the more sensors, telemetry, and data they can give the supply chain. I think that's a really important thing to start building in now as well. I think we also have to move quicker. I think that's been mentioned a few times this morning. We need to focus, get access to that data, understand the human factors that are slowing down deployment, and start introducing AI to support equipment experts. As you said at the beginning, this will not replace equipment experts. It's there to support them, take some of the heavy lifting and the grunge away from data analysis, and get them to a point they can make better, quicker decisions to keep the plant and infrastructure up and running as much as possible.
That's fantastic. John, thank you very much for joining me. It's been a real pleasure as always, and thank you very much for your excellent presentation, and we'll speak again later on. So many thanks.
No, thanks, Adam.